Okay, so I just wanted to give a demonstration of making a linear graph using the standard curve for your biotech class. This should be your introduction to standard curves in biotechnology. And we're going to use cell counts over a period of time to generate this graph. And these numbers I just completely made up. These numbers are not from reality at all. So cells were cultured and counted over a period of time. Graph the data in a standard curve using linear plot points and answer the following questions. Now the key word here is linear plot points because you want the line on the graph to go up in a nice diagonal slope. You want it to be like a straight line going up in a nice diagonal slope. So you want it to be linear. So you don't want it to go up exponentially because it's just harder to do calculations later on with your information. So the whole purpose of doing this is so we can lay a groundwork and get the slope-intercept formula so we can do further calculations on this information later on, when you're working in the lab. So what we have here, we have the time in hours column, and we have the cell count, the amount of cells after that period of time. So if you notice, this cell count is after 6 hours, there's 90 cells. After 12 hours, there's 220 cells. After 18 hours, there's 452, and so on. So this isn't going to give us a nice diagonal line on the graph. So what we need to do to use linear plot points to give us a nice diagonal line on the graph is we're going to take these cell counts and we're going to take the logs of these numbers and we're going to make a graph out of the logs of these cell count numbers instead of the actual cell counts themselves. So time, I always suggest you putting time on the x-axis, going from left to right, because that way, when you read the graph, you're reading it like a story, like things are happening in chronological order, and it makes a lot more sense. And then put the amounts of things, the cell count on the y-axis going up and down, because we can associate amounts with how high the line is, and that just makes more sense reading the graph. So for the time, I'm going to make the time the x values on the graph. And then I'm going to make a new column over here, and this is going to be the y values. And this is going to be the log of the count, the logs of each numbers under the cell count column. And here's how you're going to do this in Excel. First, let me give it a bottom border here. There we go. We're going to go to the first square in our new column that we're going to make. And we're just going to tell Excel to do these calculations for us because this is too long and complicated and involved when you have a whole bunch of data to do every single little individual calculation manually, like with your calculator. It's too much. So you need to know how to do this in Excel and tell Excel to do the whole thing for you. So we're going to go to the first square in our new column, log of the count, and we're going to go up here to this formula bar and we're going to click equals. So the equals at the very beginning of the formula bar is going to tell Excel that we're giving it a formula for Excel to do the math for us and for Excel to display the answer in this square. So we're going to tell Excel to display the answer to the formula in this square and not actually display what we're typing in the square. So we're going to type an equal sign. That's what the equal sign does. Then we want to just type log, the word log, and if you just type L, you'll see that a whole bunch of options pop up. And so right down here is log. So I'm just going to double click that. And as you can see, Excel entered in the word log and an open parentheses. So in this open parentheses, first we want to do the first cell count, which is 90 cells. And we could type in the number 90 and hit enter, and Excel would give us that information, but we don't want to do that. And the reason why is because we're going to put this on automatic pilot. So Excel is going to do this whole column of cell counts for us. So instead of just typing in the number 90, we're going to click on this square. And as you can see, Excel entered in the number D5 for us because it's in column D and row 5 is the cell count number, the 90 that we want. So we're just going to close those parentheses and then hit enter. And you see how the number popped up, the log of 90 popped up um, in this first square in our new column. So now we want to get Excel to do the rest of this cell count column for us. But we don't have to go through and individually keep typing that formula equals log in all of these boxes. What we do is we go back to this, our first answer here, first log count, and click that square on. And if you move, you see how my cursor is a fat like cross? It's going, if you move it over to this little bottom square, the bottom right of the square, see how my cursor turns into a little plus sign, a little two sticks making a plus sign? You want to get that cursor by hovering over the bottom right hand corner of this green outline, outlining the square. And then we just click on that and drag it down. And see now Excel in each row has taken the log of that cell count. See, this is D6, 220. So it's taken the log of D6 in this one. And then down here, it's taken the log of D7. Down here, it's taken the log of D8. Down here, it's taken the log of D9. So it's automatically knew that you wanted it to shift down, take the log of the next square down, take the log of the next square down. And it knew that because you highlighted the original answer with the formula in it, and you hover down at the bottom right until it turns to a plus sign, and you just grab that and click and drop down, and it does it automatically. So that's how you find the log of all of your data, of the cell counts of all of the data. Now the second part is we need to turn this into a graph. So we're going to graph the time as our x values and the log of the cell counts as our y values. So I'm just going to click on over here into a blank square, and I'm going to go up to the top where it says insert and click that on. And over here in charts, I don't know why they just don't call it graphs, but they call it charts in my Excel. There's this little chart sign down here, and it's got the dots in it. You want to click that drop down, and it says scatter chart. So you just want to click the dots, the one with the dots in it, the very first one, and it brings you up a blank window. So I'm just going to move that over a little bit. So now we want Excel to create this graph in here. So we're in chart design up here on the top, and we're going to say select data, and we can go to legend entries series and click add. And now see it has the series X values, this middle one. These are going to be the X values that we want Excel to use to make the plot points. So, and we don't have to type anything in here. Instead, you just make sure the cursor is blinking in that white space for series X values. And we're going to go over to this time column, and we're just going to highlight the whole column. And see, Excel automatically puts in a little formula telling it which data points to use for the X values. And then we're going to go down to the Y values formula bar, and it's got this equals parentheses 1 in it. We're just going to get rid of that, just delete that. And we're going to make sure the cursor is flashing in there. And then we're going to go up to our y values, which is the log of the counts. And we're just going to highlight that data. And so we're going to click OK and OK to get out of here. And see, now we have these pretty dots. We've made all these dots, plotted all these dots for our graph uh, of the log of the counts of the cells. Now we want to have a line connecting all these dots. So we're going to make sure you're still in chart design, because if you accidentally click out of the graph, it's going to go back to home. So you got to click on the graph again and make sure you're up here in chart design. And over here it says add chart element. So we're going to click that drop down, and what the name of that little line that connects all those dots in the graph is called a trend line. So we want to select a trend line, and we want a linear trend line, because that was the whole point of us taking the log of the cell counts, is because we want a linear graph. We want a straight diagonal line going up. So there's our pretty trend line. And we want to do one more thing to this graph before we go on to answering the questions. Double click this trend line, and this little right panel should pop up, Format Trend Line. And we're in linear, which is good. We want to scroll down, and it says Display Equation on Chart. That's our slope-intercept formula. And you also want to click Display R-squared value on chart. I'm not going to go into the R-squared calculations in this video, but you are going to need to do that for later. So I'm just going to show you now that it's just a good idea to get in the habit of also checking the display the R-squared value on the chart. So we can X that out. And so now see on the graph, we have this little square. I'm going to move this. And it has our slope-intercept formula and this r-squared value. Now, as I said, I'm not going to go into the r-squared value, but this slope-intercept value, if you remember, your slope-intercept formula is y equals mx plus b, where y is your y values and m is the slope, and x is your x values, of course, and b is going to be your y-intercept. And just to remind you, the y-intercept is where the line would cross the y-axis when x is 0. So if this line continued on backwards until where x is 0 and it crosses this y-axis, that would be the b, the y-intercept. So that's y equals mx plus b. So if we look at this formula that Excel gave us up here, it gave us the formula for this graph. So we have the y equals 0.053x plus 1.6727. So there's the y values. Oh, I put v values on here. It's funny. Okay, so we have our y values. And then the slope is going to be the 0.053 is going to be the slope. And then you have your x values, and your x values are whatever time you're looking at. And then you have your b-intercept, which is the 1.6727. So on our first question, what is the slope-intercept formula of the graph? We're going to write out y equals 0.053x plus 1.6727. So that's our slope-intercept formula of the graph. Now we're going to go to our next question. What is the cell count at 22 hours? Because if you look up at our time up here, we don't have a dot for 22 hours. We have a count for 24 hours and we have a count for 30 hours, but we don't have a count for 22 hours. So what we need to do is see our time as our x values. So we're going to take this 22 hours and plug it in as our x value in the slope-intercept formula and figure out what that y value is going to be. So again, now we're in this box now. Again, we're going to tell Excel to do the math for us, which means we're going to start everything out with an equal sign. And then we're going to take our slope-intercept formula, 0.053, and instead of just typing x, we're going to type times 22 we're going to plug in the 22 for the x hours, and then plus 1.6727 and hit enter, and there you go. That's 2.8387. But now that's not the cell count at 22 hours, because this just gave us the y value. And what is our y value? Our y values are the logs of the cell counts. So this 2.8387 is the log of the cell count at 22 hours. So now we need to unlog it. We need to bring it back to the actual number. We need to take the anti-log of this. So all we have to do for that, I'm going to go down one square. Again, we're going to tell Excel to do this for us. So we're going to hit equals. And then to take the log of something and turn it back into the real number, we just take that to the power of 10. So we're going to go 10 and this little caret, which means take it to the power of, and that's Shift 6, and then 2.8387. So 10 to the power of whatever the log is. And then you hit enter, and we have 689.7631677, so approximately 690 cells at 22 hours. So that's how we find out how many cells would be the count at 22 hours when we don't have an actual uh, number for that at that actual time. So that's why we needed this uh, slope-intercept formula on our graph. That's why we needed Excel to display that, so we could use that formula to do further calculations. And I hope that was clear, and I hope that helped take you through plotting a linear graph for the standard curve. If you have any questions, leave a comment in the comments below, and don't forget to like and subscribe.